That's recording too, so whenever you want to start.
Whenever I want to?
Yeah, hit it.
I will.
Welcome to GoAdditive, where your hosts combine their real-world professional 3D printing experience to deliver valuable opinions that will help you peer behind the curtain of the additive industry. And now, GoEngineer's own Tyler Reid and Tate Brown.
It's already changed things.
Yeah, you've already messed it up. You know that.
I didn't mess it up.
There's a line of sight right here that we have to keep it clear.
Oh. Well, I'm trying to lean into my microphone like I'm used to doing.
Yeah. So obviously it's a little bit different, right?
What's different?
Well, you can actually see us potentially. If you're watching on YouTube, you can see us. That's never been a thing. Right?
Yeah, it's weird. It's weird. So things might change a little bit. Oh, go ahead.
We've been talking about filming it since essentially episode 1, right?
Episode, like the hidden episode 1?
Since
or the
episode
actual
-10.
Okay.
Which is the hidden episode 1.
Yeah. Well, here we are. We've made it over a year. We're going to have an instant set of how many subscribers?
90,000 plus subscribers.
And we didn't pay for those.
Just riding on the coattails of the greats before us.
Yeah. So this is going to change the dynamic for sure. Hopefully not in a bad way.
It's not going to be bad. I think it will be a little bit more immersive and we will have a whole new audience.
It's going to be incriminating.
That could be true. That could be true. We've prided ourselves for 43 episodes of 0 edits. Outside of like some silence.
There was a bleep once. I think you added a bleep.
Yeah, what did I say?
It was a company name.
Oh, that's true. I did bleep once in 43 episodes. And it's going to be harder to do that.
Yeah, we may have to cut things out. And you, who are normally very poised in terms of what people can hear, are not always visually poised.
Yeah.
You sometimes are over here covering your mouth, trying not to laugh. The vein's poking out. Now people are going to get to see the vein.
Yeah.
They're going to get to see that. And I just wonder if you can up your game to keep that level of poise both visually and through audio.
Oh my God. I'm already failing that. I'm already failing.
He's not going to make it.
I'm not going to make it. The vein, it's going to come out.
Oh, yeah. And I want to make sure I do give a clear line of sight here with this camera.
Yeah.
Because that's the one that's going to catch it. If you can, camera people, zoom in. I'm just kidding.
Yeah.
I'm kidding.
It is kind of fun to break the fourth wall, though.
Yeah, we'll see how fun it is when people start making fun of us.
True. But we're going to be big on YouTube. We're coming after you. All of the YouTube greats. You know, Mark Rober, we're coming after you.
You're going to call people out.
Yeah, that's what you do. That's how. It's like when you go play basketball.
They're not going to even know.
On the court, right? You go to the park and you challenge the top player immediately. That's the first thing you do.
You ever get dunked on?
Yeah, but then you dunk on him back.
Okay.
Yeah.
All 5'8" of you, 5'10". What do you say you are? What's your roster height?
Okay, so I'm 5'9.5". Although now that my psoas muscles are looser, I think I grew about 1 inch. I think it was pulling me down.
So if you didn't listen to last episode, Tyler actually had a print that he made.
Yeah.
That helped him grow 1/2 inch.
Yeah, the so right.
No, it wasn't the so right. It was your ripped off version of the so right.
It was a piece of plastic that resembled the so right.
With some additional features.
Additional features, yeah. That thing actually has been a lifesaver, honestly. Feel great. I'm
Well,
fixed.
If we're talking about prints, I actually brought one with me today.
Which is funny because I don't think you realized that we were being filmed today.
No.
But you brought a visual anyway, which is pretty cool.
I was going to force you to describe it with words.
Yeah.
On air.
In order to avoid that, I made this happen instead.
Okay. So I actually just got back from a trip to LA with one of our sales guys, and I hit print on this before I left.
Yeah.
This was a 20-hour print, I want to say, and it came out beautiful.
You got to show the camera. You got to show the camera.
I don't want to show the camera.
That's what they're there for. Oh, yeah.
That's a nice looking print.
Is that ASA, ivory?
It is.
I can tell.
So probably not the best for visual demonstration because typically the support material looks, there's some contrast. But with the ASA ivory, it looks almost the exact same color as our soluble support. This one does have a little doohickey hanging off the side of our support tower.
Goober. What happened there?
I moved the support tower to the absolute edge of what is possible to print. And now I know it will go all the way to the edge and almost like do a literal cliff hanging, but it didn't affect the quality of the print. Came through really good.
I'm guessing anyone who is watching that hasn't run one of these Stratasys FDM printers is wondering, why is that build plate not rectangular? And what is that little bow tie thing?
Okay, let me describe it to you. So the call out for what this can print, this printer print area, right, is 14 by 10 in terms of just the square inches of the build platen. Stratasys adds this extra little piece. What do you think that is? Like 4 square inches? 3?
Ooh, I don't know.
They add the extra so that they can basically put this purge tower on it. What?
I would say 1.25.
Oh my gosh. That's why you made that face.
I was trying to do the math. Public math.
Okay. Yeah, you don't want to do that on the air.
I know.
So yeah, they add the little bit extra. They add this purge tower. It kind of helps with the quality of the build. It helps with the speed. Makes it so that it's not purging at the back of the machine, so it reduces some of the head moves. And they don't want that to bite into the advertised printable area.
Okay, got it.
So it's pretty cool.
Yeah. As you're holding that, I just want you to crack it. That's all I can think about.
I've been
just
waiting
how
all
satisfying
morning.
it will be, unless you botch it, and then you will have 90,000 viewers watch you botch it.
Can you
So
describe what I'm doing to our people who aren't watching live action?
You're cracking the parts off the build plate,
which is relatively easy. Oh,
go.
What is this called? ASMR?
Yeah.
Oh, that was nice.
Nice. Do it again.
Ooh,
that's pretty good.
Let me just do the 2 more.
I think this should be a regular segment.
Oh, check this out. This one's leaving some. That's what I wanted.
That's
right
the best.
There. That's a clean break.
That's best case scenario. Leaves the raft right on the build plate. Although now you have to scrape that off. Probably.
No, that'll peel off pretty easy.
You think so?
Yeah, I like it best when these are warm. This has had forever to cool down.
Yeah.
But you'll get different results when it's warm.
So this print is from your project that you talked about on the last episode.
Ooh.
Is that right?
That's nice. Yeah, this is the tube straightener, and I actually printed the wheels. Did you see how easy that was?
Yeah, it just popped off.
It just made
instead of doing the bearings,
I have the bearings at home, and I knew after I bought those bearings, I was like, someone I know has a ton of these bearings somewhere, but I'm too lazy to ask. And like within minutes of me telling you I needed some bearings, you're like, oh yeah, I have a whole bunch of those.
Yeah.
So I felt pretty dumb, but I printed the wheels or the tires, I guess you would call these. The profile of these little guys will fit that 3/16 diameter tube just perfectly. And I'm not going to keep doing this.
How much compressive force do you think are going to be on those?
I don't know. It's real hard telling.
Yeah.
So they go together like that. You see that?
Yeah. And so from 4 sides,
look at that,
like a 4-jaw chuck.
It's like a half a moon there. Ooh, yeah. Half moon. Anyway, I printed the tires. We'll see how it all fits. I have no idea till I get home and try and put these on the bearings. But I do want to get to a tech tip.
Okay. Tech tip.
FDM Tech Tip.
Tech tip.
Tech tip.
Tech tip.
We need an actual sound effect on our board.
Yeah, because I never want to do that again.
What did I do here?
Ooh. You printed diamonds. I was trying to work in a Rihanna reference there.
Oh my gosh.
But that's probably not an area I should go into.
So because of the print orientation and the counterbores on this part, I wanted the counterbores to be, their axis to be straight up and down in the Z. And so I printed it like that. And then I printed the horizontal holes that are perpendicular to that axis. It would have printed support had I left the holes full size. GrabCAD Print has this feature called make self-supporting, or make holes self-supporting.
Yeah.
And you can just click the cylindrical face and make those self-supporting, and all it does is change it to a basically a diamond shape, which will speed up the print. It reduces some of your support material, and I think it makes things look better. Also, it adds one step of post-processing. So I'll have to go drill those now, but I'll get a better, more round hole with a drill, right?
That's true.
Than I will just printing.
That's true. Yeah.
So my tech tip is, when you can, change out a hole that you know you can drill out later to a diamond.
Yeah, self-supporting diamond. You could do that in the CAD tool if your slicer doesn't support that. But sometimes it's nice to do it in the slicer. For many of our customers who are working within like a controlled space in terms of file management, they wouldn't be able to do that, right? Because they potentially...
It would be a print-specific file.
Yeah. If you're making changes outside the CAD, that could be problematic for some people, but I would say most users could do that no problem.
Yeah. And does this only affect people with soluble support? No. This will affect people that are using model as support too.
Sure.
Because the Prusa is doing breakaway support with the single head, so that'll help you all out. It's a lot cleaner way to get a nice round hole.
Yeah. Cool. I like the show and tell. Yeah. There's been so many times where we wanted to bring a model in, and just describing it in words just really would always leave. It's like the most important sense, when we're having a discussion like that, sight. So perfect day to unveil it. Our YouTube debut.
Yeah. What a coincidence.
Yeah. What a coincidence, for sure.
So let's talk news.
Okay.
I don't have any news. Like I said, I've been traveling. I haven't been keeping up with things. So fill me in.
Okay. Well, I do have some news, and just a warning, if you have been listening, you may understand this dynamic of when Tate brings the news, it's pretty interesting. And when I bring the news, it's usually pretty dry. So just a heads up there. Well, speaking of dry, I actually think the coolest news story that I've seen this week was out of NASA JPL, which is a customer of ours, but we don't have any association with this project. For the last 5 years or so, they've been investigating creating porous metal prints on their laser sintering systems by essentially a controlled degradation in the laser parameters. So when we're laser sintering metal powder, primarily our target is full density. We want like 99.5% density or higher, right? And so we develop laser parameters. Oh my God. It's already too dry, isn't it?
No, keep going. We'll suffer through it. This is getting back to the metal headphones.
Is it?
It's pretty bad. No, I'm just kidding. Go ahead.
Okay.
So we're targeting high densities.
Typically, you would target high density. You're printing parts and you're trying to avoid porosity. But just like in FDM, we use porosity in FDM to enhance the functionality of the parts in some ways, right? Like if we wanted to pull air or water through a part for various reasons, like a thermoform application,
Pulp.
Yeah, we actually create tool paths that degrade the quality of the part visually and mechanically. We build porosity into the part. And that's what the team at JPL has been working on the metal side. Essentially printing, you could think of it like a sponge.
That's what I was going to say.
Yeah, like a sponge. And they released their paper, which I can't read. It's a research paper. And although I still have a login through
You can't read?
The words are too big. The words are too big. No, I actually still have a login from school when I graduated 13 years ago. My login still works and gets me access to a lot of different journals. But the journal that they published this one to, I don't have access to, unfortunately. So it's a very academic article. And I want to read it. I'm going to try to get my hands on it. I'll probably message, I think, Doug Hoffman, and see if I can get it. But anyway, they released some GIFs of, like coasters printed in this way that were absorbing the water in selectively. So as it absorbed the moisture, it was changing the color, right, of the prints because they're wet. And it was revealing images and things like that they had, so you could see how they had controlled the porosity within the print. Does that make sense?
Yeah, totally.
Very cool. Very cool.
Where can we find these images?
The internet. You could search JPL 3D printed porous metal, something like that. And that will pull up a variety of news articles.
Ooh, found it.
Yeah. Google News is the way I would recommend searching for that.
JPL porosity test.
So you should see some images there.
Yeah, I do see some images. And you can't.
Yeah.
I'm glad you can't see my screen.
It's a more advanced
it's probably better you can't.
Yeah. It's a more advanced thing that we might have to do in the future for YouTube is get a screen share.
It's going to need to be able to be turned on and off. You know what I'm saying?
Yeah, for sure. We could do that. That could be arranged. So do you see those images though? How they have
Yeah.
So they were able to find some process parameters that when sintered kept rigidity within the part, but also added porosity. And they could control that porosity up to like 43%, give or take, and down to, I think, single digit porosity. And you could use it for all sorts of things. Imagine something like a heat exchanger or some sort of filter. Types of parts that would benefit from a high surface area ratio.
I like it.
Right? And you could never design that. At least with any tool that I'm aware of.
The porosity?
In the CAD tool.
Oh, yeah. That'd be tough.
Couldn't.
That'd be tough.
Maybe an implicit
you'd need
CAD tool.
A nice little API for that.
API. That's actually a good segue to another news article that is newsworthy. I'm actually a little upset about it.
Okay.
Yeah.
I think I am too. I know what you're talking about already.
So we use GrabCAD print to process a lot of our prints, through Stratasys. And for the last little bit, they've been working on an API to bring in third-party plugins. And one of those plugins that we were really highly anticipating was from a company called Teton Simulation. And I think we may have talked about it on a pod.
I think we did.
I think we did too, where we could bring in the CAD tool into our standard preprint software and apply some loads and get toolpath optimization based on those loads. So in the same way that we were just talking about adjusting the internals of the metal parts, we can obviously adjust the internals of the FDM parts, but standard slicers really only give you the ability to do solid, sparse, somewhere in between. And in GrabCAD, we can grab faces and tell a certain face to be thicker. But the level of control is not great. And it's based on just manual inputs. So what the simulation tool would do is say, hey, based on these loads, if your goal is to optimize for, say, strength to weight, we could carve internal weight out of a part in this area and add density in another area. Am I explaining that well?
I'm not listening.
It was called Smart Slice. Wow.
It's not that I didn't want to listen. It's that I'm trying to make sure that we answer to things that we've promised.
That's
in the past.
That's very cryptic.
I don't mean it to be cryptic. I just am saying we sometimes make promises that we don't keep.
Okay.
And I'm trying to be more proactive.
Okay.
So I did actually make notes on things. Let's see.
Are you looking up old notes?
I'm looking up notes I made from last episode.
Oh, okay.
Yeah.
To see if we had promised anything last episode.
And there is one thing. I'm going to try and get an answer live action.
Okay.
Right
now. Yeah, I mean, let's drop what I was talking about and let's go to this.
No, finish your thoughts, please. I just was saying that as a side note, we do need to follow up and keep our promises.
All right. So long story short, Smart Slice is a plugin that we were looking forward to having. And it was just announced yesterday that Mark Forged bought Teton Simulation, the creator of that plugin, and they're going to integrate it into their Eiger software. And I think that was a good move by Mark Forged. So kudos to them. That's a good move.
That stinks for us.
It does stink for us. Although the API now is there, the bones of the API are there, and it's a functionality that is still a little bit premature, I would say, just in general, what's out there. And we were already on the path of educating people about the importance of it. And I do think it's one of those tools that will eventually be integrated in a way it's used, pretty often. But in order to even get use out of it, you have to know and understand the loading conditions of your part, right? And so, like, take your tube straightener right there. You couldn't use that because you don't have any idea what's going on.
Whoa, easy, pal.
You don't. I asked you, how much compressive force are you putting on that?
I honestly don't think that it's not preloaded. So it's going to go under force depending on how bent the tube is.
Yeah, but it's going to see force, right?
Yeah,
so
I suppose, but it won't be uniform.
So you would have to quantify it.
Yeah, I get the point you're trying to make. One, it's embarrassing for me, but two, yeah,
you shouldn't be.
Because you have to know the loads in order to make a good simulation,
right?
And you can't make good parts based on simulation unless the numbers are accurate,
right? So we talked about this in depth on the topology optimization episode, 20 something episodes ago, where it's great technology, but you have to know the loading conditions and you could steer yourself in the wrong way. So oftentimes, if you're trying to balance like how you spend your time, you just print it solid. Now with larger printers and like on an F770, for example, where the prints could take days, weeks, there's a significant incentive to, make more efficient use of your material there. As the parts get smaller, I think there's less and less room for, efficiency. I mean, there is.
I'm getting an answer. I'm getting the 3 dots.
Okay.
From Jeb.
Okay.
Our tech Jeb.
Yeah. What was the question?
So what are the consequences in the origin system by leaving a part to saturate in raw resin.
Oh, gotcha.
Remember that?
Yeah, we did talk about that last week, and really we didn't. We guessed.
We guessed. And if I know this Jeb, like I know this Jeb, this is going to be a well thought out response.
Do you dare just read it word for word?
I don't know if I dare. It looks like it's going to take a while because I've seen these 3 dots just hovering.
Okay.
For the last minute or two.
While you're waiting for that, should we jump to the next thing that I kind of want to talk about?
Yeah, please.
Okay. Do you know the company Anker? ANKER.
Hold on.
Does that sound familiar?
Never heard of them. Of course. I don't think, has there been a time where you've done this and I've known the company you wanted to talk about?
I'm not going to answer that.
Okay, got their website up.
Okay, so
looks nice.
They actually do a great job.
It's a nice looking website.
I think their marketing is awesome. And that's not a dig at all. I think their marketing is really good.
So what about them?
Okay, so this is a company that I've purchased several of their products just through Amazon. Initially, they would import products from overseas and just kind of white label them. But I think that they started to develop their own products.
Okay.
Mostly chargers. So think USB chargers, phone chargers, that sort of thing. And yesterday they launched a Kickstarter for a 3D printer. And the reception has been actually pretty overwhelming. A ton of energy behind it. A ton. Did you get an answer?
Why are they launching a Kickstarter? They look like too legitimate of a company to be like.
Yeah.
They say save 21% on their website by backing their printer. They've got a nice picture of it. It looks nice.
When reading through the Kickstarter campaign, I was thinking
it's tiny.
If I wanted to buy a machine, I would probably give this a shot. I mean, we were talking, what was it, last week?
Why?
Because I'm falling victim to their marketing for sure. Although a little bit over the top because they have like trademark names for almost everything.
Give your prints power boost,
ultra boost, like
cut print times by 70%.
That's their big claim, is that it's going to go like 5 times faster than like a Prusa Mark III.
Let me read this.
Okay.
So if anybody doesn't have time, or if this sparks their interest, see 5 times faster, 250 millimeters a second printing speed with acceleration up to 2,500 millimeters a second.
Whoa. That's the wrong units.
Sorry, not a second. Millimeters squared. My bad.
Per second.
Yes.
Okay.
Here's what's behind the turbo times. Thank you for catching that. I do that kind of stuff all the time, and I know people just don't say anything, and they're either confused or they know that I'm wrong.
Yeah.
So thank you for correcting me. Here's what's behind the turbo times. Y stepper motor with high subdivision drivers, improved torque and stability, double belt that provides even power distribution, advanced algorithms, that align your printing with your course of action.
Okay.
How would they know?
I like
those are some algorithms.
Yeah. The high subdivision drivers, that actually doesn't promote speed. That slows things down. If you have stepper drivers that have,
it's like a torque multiplier, right?
Well,
it's like it slows things down.
It not in that way, physically, but the data rate. If you're pushing more data and you have a certain bus speed, like more data isn't always the best, and it definitely doesn't help promote speed. So that's just interesting.
It looks nice for an open air system.
It does look nice.
And that's all I can say. They've taken some time with an industrial designer to make it look sleek.
I think it would, if you were in the market for a machine like that, honestly, I would still defer to a more well-established vendor like Prusa. I mean, because I think you and I would agree that the hardware is not the most difficult part in this product development.
Yeah.
It's the algorithms. It's actually getting the material out and creating awesome prints. Now the prints do look amazing, but we've talked, this is a recurring theme on this pod, is that you have to take everything with a grain of salt and be very skeptical, whether it's a hobbyist machine or a professional machine. Be skeptical of everything you're told.
Kind of like our print 1,000 times faster.
You love that title. Why do you love that title so much?
Because it's so, I don't know that you meant to be like really gimmicky. Maybe there was some, intent behind it. But that episode to this day gets the most hits.
By a lot.
Yeah.
Like by a big margin.
Yes. And so it's like, I feel a sense of guilt over it, but these print companies, they're not going to feel guilty. If they tell you they can print 75% faster, the proof's in the pudding. So it's like, print me something and we'll see if it actually prints 75% faster then. But this is when someone on that team will typically be like, well, it will, but
Usually there's some context to that. And with any benefit, there is usually a disadvantage as well. So, I mean, we can't say one way or the other.
You can't have your cake and eat it too?
Yeah, that's the saying.
That's a darn shame.
But here's the thing. I think it's super exciting because the Kickstarter shows just how much energy there is in the 3D printing space. They launched yesterday. They already have $3 million. They passed the $3 million mark in backing in less than a day. That's amazing.
That's incredible. I don't know. I don't know what to say. It's a shame it's just another desktop printer.
Yeah.
Like, I don't know. I'm curious to know what the people who backed it see in it, or if they have experience, or this is a first time printer situation, or if it's like, no, I really hope this one's going to be better than my last one.
I think that you're going to have a mixture of both type of buyer. You're going to have a mixture of people who have existing printers that have some frustrations, because we know that running those machines is not the easiest thing. You have to have some patience, right?
Mm-hmm.
So you read their release and you think, okay, this looks like it just works. So I'm gonna take the chance and upgrade. And then you have people who are familiar with their products, because they do sell good charging products. And you see the polish of how the whole product is presented to you. And with the Kickstarter campaign, how they tier out the release. So if you're the first 200 backers, if you're the first 2,000 backers, you get a significant discount. That's probably a big reason why they launched it through Kickstarter, because you get to feed off that excitement of getting the discount. And so they think, okay, well, I'll take a stab at it. I can pay $400 or $500. And worst case, if I don't like it, or if it doesn't meet my expectations, then I could sell it to someone at the end, probably for more than I paid for it.
Did you actually see the price of it on Kickstarter?
Yeah.
What was it?
So for the first 200, it was like 400 something. And then right now, I think it's at $599. Retail is supposed to be $749. Yeah. So
it's competing right there with the Prusa.
Yeah.
Price wise and everything.
Yeah. So, it's just another printer.
I do get it from the standpoint of, you trust certain brand names.
Yeah.
It's like you trust a certain actor.
Right.
Like, or actress.
Yeah.
You see them in a movie and you're like, I'll see it. I'll watch it.
Sure.
You don't know anything that it's about, but you're like, that person doesn't take bad roles.
And that's where the strange thing is, like, if it's a trusted brand, why are they launching through Kickstarter?
That's, I don't know. Cause they could offer a discount through their website.
It's because they were able to raise, $3 million very quickly. So I think Kickstarter has changed a little bit from its like original intent, sort of like GoFundMe.
Yeah.
GoFundMe.
Oh, don't even go there. I don't want to go there. It's too sad.
It's a healthcare provider.
Oh my gosh.
Yeah, it's terrible.
Yeah, I didn't want to go there. That's what it is.
Yeah.
Yeah, I don't want to talk about that.
I know, right?
Let me
on our YouTube debut. You don't want to dive into
no.
It's hardcore politics.
No.
Neither do I.
Let's talk about YouTube.
Okay.
Now we kind of already alluded to YouTube a little with the fact that you and I are in a way kind of cheating the system.
Totally.
Sort of like Anchor is.
Anyone who watches this, we didn't earn your view.
Yeah.
I will fully admit that.
And maybe that needs to be the clip that when they click on it.
Yeah.
They need that because we didn't earn the 90,000 subscribers. So we're kind of cheating our way in. We know it. We may get some.
We did contribute to building the 90,000 subscribers.
That's true.
I have videos on our YouTube page that are approaching 10 years old.
Congratulations.
Thank you.
That's actually really cool.
Well,
I've watched some of them, by the way.
Well, this is one of the most exciting things about being on YouTube is that the content stays. So very rarely would you go back and listen to old podcast episodes or organically discover a podcast episode that's 8 years old. But on YouTube, you do it every day.
I actually don't watch podcasts on YouTube. I'm not one of those people yet.
Yeah.
And that could change, but I'm not a huge podcast consumer as it is.
I'm a mix. It kind of just depends on where I'm listening. If I'm in the car, obviously I'm not. But if I'm in the garage, I'll usually turn on, and the YouTube is an option, I'll usually turn on the YouTube.
My struggle is finding a good podcast. So I feel like I'm just constantly looking, and I feel bad for those folks that have done that with our podcast. Like, yeah, it was good for an episode or two. See ya.
Yeah. Well, here's another thing is how you discover podcasts. You pretty much have to search for a podcast by name.
Or be recommended from another source that you trust.
Yeah. Yeah.
Right?
Word of mouth.
Oh, yeah.
Word of mouth.
Yeah. Check this podcast out. It's got so-and-so.
And they'll tell you the name.
Yeah. And then you go follow it up.
YouTube, it's discovered by other ways, by the content.
So we're going to see. We're going to see what happens. This will be a little experiment.
This could be the beginning of the end of the podcast. Let's just put that out there. It's totally a possibility. But yeah, it's easy to overcomplicate things. I was actually going to print a part last week. And so I have we have a sandblaster. And if you don't, we.
Oh, do we?
I mean, it's technically the office's, although.
Where is it?
It's a little cramped.
Where is our sandblaster?
Okay, we didn't have air. But I did have air at my house. So I had to move it to the house for a short period of time.
Okay. So GoEngineer's sandblaster is at your house?
Yeah.
Oh, I didn't even know we had one.
Hey, if we're going to be tallying things, definitely I have a lot more stuff here than the opposite.
Okay.
So anyway.
All right.
It's
a trade.
Yeah. Okay. So if you, on these sandblasters, you'll etch the glass, you'll etch the plastic if you don't protect it. And so I went out and bought a piece of glass, but it broke because it wasn't tempered and I didn't want to deal with that. And so I thought, okay, well, I'm going to print an inner frame and get a tempered piece of glass and it'll be permanent. And I went through and I started designing it and I was like, this is dumb. I'm just going to go buy a shower curtain, like a clear vinyl shower curtain and just tape it to the inside. It cost me $6. I'll get probably 10 of them out of it and just be done with it. And so sometimes when you have a printer, you do, or any tool, you do sometimes overcomplicate things almost as just like a crutch because you become so used to using that tool. You think so? Do you agree?
Yeah, I do. And so there is a balance. There's a balancing point where it's like, I'm just using this to use it. Now, if you're trying to get ROI on it, even then sometimes that might take it a notch further in terms of, okay, yeah, my threshold used to be here. I'm holding my hand at a certain level, which you can see on YouTube. But now because I'm trying to get ROI, it might move that threshold a little bit higher. But even then, there's still kind of like the break-even point where it's like, I'm not even close.
Yeah.
And that's where you ran into with your project.
Yeah, for sure. All right. Well, that about exhausts the news stories I had. I think next week we might talk a little bit about AMUG, which is happening right now. Obviously, we aren't there, but
we did a live show there last year.
I know. It was a lot of fun.
Yeah.
Such a good show. Good industry show.
Sad not to be there.
I know. Did you have anything else you wanted to talk about before we wrap up?
No, I reamed those holes.
Oh, yeah.
I reamed those holes and it worked.
Nice.
Whatever method I told you I was going to do, that's what I did.
Cool.
Dove straight in.
Cool.
Beautiful.
Our YouTube.
I'm practically a machinist now.
Yeah, practically. Our new YouTube listeners will learn that we sprinkle in a little bit of Tate's Bronco project into every episode.
Oh, there's some of your project that's going to come in next episode.
Probably.
Sure.
Probably.
All right.
All right. Well, that's a wrap. That's not that bad, huh?
It was pretty bad. In terms of suckiness, that was like a 5 out of 10.
You know we're still recording the episode, right?
All right, man.
Yeah. Okay. Well, let's talk next week.
Okay.
Later.
Adios.